For this section, we're going to be doing questions 2 and 3. Questions 2 and 3. Let's take a look at 2. It says the equation y equals 2x minus 1 is graphed below. Identify the domain and range. Are there any restrictions? Are there any places where it doesn't exist? Are there any places where the graph turns around or hits a valley, stops? No. So this is going to be all real numbers. And the same goes for my range. All real numbers. What is the y-intercept? Now remember, y-intercept is where it crosses the y-axis. So it looks like this point right here, which is located at 0, -1. All right, identify any relative or absolute minimums. Does it ever reach the lowest point it can go? No. It continues on. So that would be none. Does it ever reach the highest value, maximum? No. Keeps going on. Explain whether this equation represents a function and how you determine this. Now remember, in the last lesson, we talked about the vertical line test. So that if I have this horizontal line that runs across my picture, not horizontal, sorry, vertical, runs across this picture and only touches one point at a time, it is considered a function because no y value is being used, no x value is being used more than once. Well, this would be explain if this represents a function. Yes, it is a function. It passes the vertical line test. Number 3, the function y equals 2 to the x is graphed below. Identify the domain and then turn around and identify the range. Well, domain, it looks like it's continuing out on both ways in the x-axis because it's going to continue to keep going this way. Okay, and it's going to continue to keep going up this way. So this would be all real numbers for my x. So domain, all real numbers. What number is it not going below in my y values? I agree. Has to be, set notation is going to be y is greater than 0, but does not equal. Notice I did not put the equal to. It says, what is the y-intercept of this function? Remember, y-intercept is where does it cross the y-axis? That looks to be at 0, 1. Nope, sorry. Yeah, 0, 1. I don't know, I'm second guessing myself here. Let's look at C and D to finish out this question. Still looking at this graph, identify any relative or absolute minimums. Well, it doesn't go below 0, but the problem is it doesn't actually touch 0 either. So we have no minimums. Same goes for the maximum. It never actually reaches the highest point, so no maximums. On to your debriefing question.